for this question, it's kind of up to you how you want to deal with it. Like, it is very bearable to FOIL this out and then FOIL again with that. Like, that is a very bearable thing to do. It's not too ridiculous. So you could FOIL twice, or if you wanted to, what you could do is you could do log differentiation. And I think by this point we've done a lot of log differentiation, but you could split it up based on log properties. And just because log differentiation is kind of the harder one, I'm going to go through that. But honestly, like, you might find just foiling it is a lot easier than doing log differentiation. Okay, but just to kind of show the process, what you would do is you would say this is equal to y, and your first step is that you would take the natural log of both sides. Okay, and the whole reason why we're taking the natural log is we're hoping that we can simplify something. Okay, so we take the natural log of y here equal to natural log of this big mess. And you'll see that these log properties really help us here. So this is my new argument. Okay, so then I use my log properties, and I do have this log property that says 1 multiplication inside becomes 2 logs added. So what I can do on the right-hand side is I can split this up into natural log of 2x plus 8 plus natural log of x minus 7, and by the same token, this multiplication would become plus natural log of 3x plus 6. On the right-hand side, natural log of y. So I take my log and I simplify. Once I have simplified it, I would then take the derivative. And in this case, because all of these are ln, I would have the arguments in the denominator and then the derivative of the argument in the numerator. So this would be like our little u prime over u rule. Okay, so we talked about how the left-hand side is always and forever y prime over y. You can always write that down. The right-hand side, we put the argument in the denominator, and then the derivative of the argument is just 2. Plus, put the argument in the denominator, the derivative is 1. Plus, argument in the denominator, the derivative is 3. Now, the third step and final step is that you have to get y prime by itself. So you multiply by y and then substitute back in your definition of y. Okay, so what would happen here is I would multiply this side by y, those cancel. Then I multiply this side by y, nothing cancels, and I substitute in what the definition of y is. And that definition, again, comes back up from the very top of the problem. This was what y is equal to. That's what we're going to substitute in. Okay, so we're going to have y prime is equal to, and then I substitute in my little y, and I write as small as I can so I can try to get this on one line. 3x plus 6, okay? And then I'll multiply that by the 2 over 2x plus 8, which could reduce to 1 over x plus 4. And then plus 1 over x minus 7, plus, and this could reduce to 1 over x plus 2 if you factored out a 3 from both sides, or we can just leave it like this, and that's fine as well. Okay, so that would be using log differentiation, and if you FOILed all of this out, you would get the same answer when you FOIL it at the beginning.